All right, this is an equilibrium question where you're looking at the images and figuring out the Kc from the images. So Kc is equal to the concentration of the products divided by the concentration of the reactants. And then each of those concentrations are to some power based on the coefficients in the balanced reaction. So if you look at the progress of the pictures, you will see that you have the red and the yellow. So they told you that red is A, but also the amount of A that are in the earlier pictures versus the later pictures, the amount goes down. So the first image has 28A and the last image has 16A. So that tells me that A is a reactant. And then they say that blue is B, and initially there are 12 blues, and at the end there are 24 blues. So since that increase, that tells me that the blue is the product. So so you have your B is your product and A is your reactant. So, if you look at the last image, as long as that is the reaction in equilibrium, you can use the value to find your Kc. But we do need to double check and make sure it's in equilibrium. So if you look at the last two images, they look the same. They both have 16 A's and they both have 24 B's. So that tells us that the reaction had enough time to reach equilibrium. And then one last thing that we have to look at, which this problem didn't have too many complications in it, but just to double check, we need to check the ratios. So we started out with 28 A's and we ended up with 16, which meant that A went down by 12. And we started with 12 B's and ended with 24, which means B went up by 12. So for every A we lost, we made one B, so that does mean it's a 1-to-1 ratio. So when I plug in my numbers to find Kc, the concentration of the products is 24. The value of X is 1 because it would be a 1 in front of the B in the balanced reaction. And then the reactants are 16, and again, it would be a 1. And so the Kc of this reaction is 1.5. The chart that I used here is called an ICE chart. Your initial, your change, and an equilibrium. They tend to be kind of useful for keeping all the information straight. So I thought I'd use this problem to introduce it. I hope that helps. Have a good day.